Okay, let's do one more quadratic equation. And what we're going to do on this one is we are going to include how to draw the point of intersection. So I've given the equation h of x, but I'm also given a restriction that says x must be positive. Negative x's are not allowed. That's given to me. Beautiful. Okay, let's do inverse function. So our inverse function is going to be, start with y equals 2x squared, x equals 2y squared, x divided by 2 equals y squared, y is equal to plus minus the square root of x over 2, and there was a given restriction that said x is greater than or equal to 0. So beautiful. I don't lose marks for that because it is given to me. Okay, that's awesome. Now, I have that. I can sketch them real quickly. Actually, before we sketch, let's do the point of intersection without the graph real quickly. So the point of intersection will be the point where the two graphs are equal to each other. Point of intersection can be done in two possible ways. Option number one is we could say that the h of x, oh, I didn't rewrite this one. So this is h minus 1 of x is equal to plus minus square root x over 2. Okay. So option number one is where I say h of x is equal to h minus 1 of x. That's one option. Option number two, when it comes to that, is that I can say that the h of x is equal to y, where this y in particular is my axis of symmetry. Now, if you remember, my axis of symmetry is always y equals x. So I'm going to do the long way and then the short way for you quickly. We said that h of x is 2x squared, and h minus 1 is plus minus square root of x over 2. Okay, so I can solve this. And the way I solve this is we can square both sides. So now we have 4x to the 4 is equal to x divided by 2. Multiply both sides by 2. 8x to the 4 is equal to x. Take x over. 8x to the 4 minus x equals 0. Take out the highest common factor, which is x. You have 8x cubed minus 1 equals 0. That is a difference of cubes. So you can write x equals 0 or 8x cubed minus 1 equals 0. That means that 8x cubed is equal to positive 1, and that means that x cubed is going to be equal to 1 over 8, and x is equal to 1 over 2. Okay, that's one option. Now, once you got that, you can substitute that in, and you can say, okay, if x is a half, then y is also a half. That's the long way. The short way that we can do it is if we take the h of x, which is 2, let's go in orange, 2x squared, and we make that equal to our green x, axis of symmetry. Then what do you have? You can take your x over, 2x squared minus x equals 0. Take x out, 2x minus 1 equals 0. X equals 0, or 2x minus 1 equals 0. So that means that you have 2x equals 1 and x equals a half. And because of this statement here, that y equals x, you can then say that y equals a half as well. So according to this one, we have 2 points of intersection. Our first point of intersection is 0, 0, and our second point of intersection is a half, a half. According to this one, our 2 points of intersection is going to be 0, 0, And our second point of intersection is going to be a half, a half. Both of them work. It's just that the orange one is a shorter way of doing it. It's just quicker. Okay, so we got 2 points of intersection. Let's sketch the graphs real quickly. Okay, quick sketch. I need to point something out. Did you see this restriction that came with the question? The question itself said to us that x must be greater than or equal to 0. That means that this must be removed. And if that one's removed, that one's also removed. In other words, we have a restriction that tells us to stop here. We can't go over that line. So let's sketch this now. So we're going to say, okay, 0, 0, 1, 2. Okay. This is going to be our first one. This is going to be your h of x. But I don't draw the one on the left-hand side. And then my g of x is going to be 0, 0, 0, 2, 1. So 2, 1. And again, I don't draw the one on the other side. Okay, so those are my two graphs. And don't forget your axis of symmetry, y equals x in a dotted line, y equals x. Okay, so that there is going to be our point of intersection and sketching our inverse graph.